These are the shortcut rules. They're going to save us a little bit of time when we are doing derivatives. So the first rule that we're going to talk about is the power rule. The power rule is the rule that every other shortcut that we use is going to be kind of based off of. So if my function is some constant times a variable x raised to the n power, then its derivative is the power times the constant times the variable, and then I lower the power 1, so 1 minus n minus 1. If my function is a constant alone, f of x is just a constant, then my derivative is 0, and that's because it would be when I think about a constant, f of x would be the constant times x to the 0 power, and so that power rule would be 0 times the constant x to the 0 minus 1, and so that 0 times anything is 0, and that's why that becomes 0. So when I look at this problem number 2, dy dx is just another way of saying a derivative of y with respect to x that is 0, because this is 4, which is a constant. Okay, so now when I'm doing when I'm applying, the power rule, as in number 1, f prime of x, it'd be 5 times 4 x to the 5 minus 1 power, or 20x to the 4th. And you can go through them sort of quickly. Once you get used to it, it's just power multiplied in front and then lower the power 1. As I work through them, I can have negative powers, I can have fraction powers, it doesn't really matter. So for number 3, f prime of x is negative 4x to the negative second, because that would be negative 1 minus 1, minus 15x to the negative 4th. Again, that would be negative 3 minus 1. So negative 3 times 5 is negative 15, x to the negative 4th. You could write this as negative 4 over x squared minus 15 over x to the 4th, but most of the time I'd leave it in this form. That would be my final answer. And for these, when we're working on these, you don't need to simplify them at all. You probably heard me mention that in class. So dy dx is 16x to the 3rd, 4 times 4, x to the 4 minus 1, plus 10x to the 1st, I don't have to write the first power, 2 times 5, lower the power 1, plus 3 halves times 4. So here I'm going to be doing 3 halves times 4, which is 6x to the 1/2, and then 3 halves minus 1 would be my power. This would be the number in front. That's the 6, and then the power. 3 halves minus 1 would be the power. That would be that part. And then plus 0, which I don't need to write. And so my final answer would be that. Okay? Then we do the product rule. Product rule uses the power rule as it goes through it. So if my f of x is a product of two functions, then my derivative is first times the derivative of the second plus the second times the derivative of the first. And then again, I'm just using the power rule. So for this next one, f prime of x is the first as is times the derivative of the second. That would be 2 times 3, 6, x to the 2 minus 1, first power, plus, because that's a constant, 0, plus the second as is times the derivative of the first. So that would be 5 times 5, 25x, lower the power 1. That's how I got 25x to the 4th. Plus 4 times 2, 8x to the lower the power 1, x to the 3rd. And then the 5 becomes a 0. So first d second plus second d first. First as is, derivative of the second, plus the second as is, derivative of the first. So for number 6, I'm going to do dy dx is the first as is times the derivative of the second plus the second as is times the derivative of the first. And that's it. No simplifying necessary. Just leave it as is. Go through the power rule on each of them. First as is, the first as is, derivative of the second, 5 times 5, 25, x to the fourth, plus 0, which I don't need to write, plus the second as is, times the derivative of the first. So the derivative of the first would be 4 times negative 2, negative 8x. Then I lower the power 1, so it's cubed, plus 0, which I don't need to write. All right, quotient rule also uses the power rule. And so the quotient rule looks like this. If my function is a quotient of 2, then my derivative is the bottom times the derivative of the top, that's what that little prime means, minus the top times the derivative of the bottom over the bottom squared. So bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. So if I'm going to do this next one, f prime of x would be the bottom as is times the derivative of the top minus the top as is times the derivative of the bottom, oops, that's a first power, over the bottom squared. And again, I'm just doing the power rule, so the derivative of the bottom would be 10x to the first power plus 0, so that's how I got the 10x to the first power. The derivative of the top would be 0, so that's how I put that in there. Again, going through that process, it's the bottom as is times the derivative of the top minus the top as is times the derivative of the bottom over the bottom squared. Bottom as is, derivative of the top, again the derivative of the top, 3 times 4 is 12x, lower the power 1 squared, plus 2 times 2, 4x, lower the power 1 first. That's how we got the 12x squared plus 4x. And then the last one, same process, f prime of x is the bottom as is times the derivative of the top minus the top as is times the derivative of the bottom over the bottom squared. Okay? Hope that helps. If you have any questions, just please email me or let me know.